Welcome to qnawire.
Okay, so we have this alkene, and we are reacting it with Br2, so it's addition of bromine across a double bond, and you do have the correct product shown to an extent, right? But what you need to show is the stereochemistry, right? So recall that this reaction proceeds through a bromonium ion intermediate. What do I mean by that? It means this double bond swings open to attack bromine at the same time that this bromine attacks the other carbon of the double bond, while this bromine leaves. And that what we end up with is bromine being attached to two carbons, but attached at the same face of those carbons, right? So bromine is being bound to both of those. It's got a positive charge. Bromine with two bonds is always going to have a positive charge. And we still got Br minus, right? But the idea is that this is sort of like, it's almost a bit like an epoxide, right? They're on the same, the bromine has to be on the same face. Now, when this happens, there's two ways that this can happen, right? So it can add both to the top face, right? Both bonds to bromine are on the top face, or we can end up with a situation where both bonds to bromine are on the bottom face, right? So it's kind of like, was the bromine above the double bond, or was it beneath the double bond? Okay. Now, the final step after this is that this Br minus will do backside attack on one of these carbons, right? Similarly, this bromine will do backside attack on one of these carbons, which in this case means coming from the top, okay? And so we're going to get a mixture of products because note, theoretically, this bromine can attack here or it can attack here, right? Now, just like when we consider the opening of epoxides, we may note, hey, this is a tertiary carbon and this is a secondary carbon. Is there a preference in terms of attack for bromine? And in fact, there is, right? Bromine is more likely to attack the more highly substituted carbon. So let me clean up this structure a little bit. So okay, we'll do that over here as well. And the reason for that is that in some sense, we can think of this bromine as being in resonance, even though it's not technically resonance, just like we do with epoxides. But in some sense, we can think of it being ran out of room on my. Okay, in some sense, we can think of it being as if the bromine has what it would be like if the bromine were to have left already and put a positive charge on this carbon. And selectively, if this were to happen, this would happen where the positive charge goes to the tertiary carbon, right? So in that way, we can think of this carbon as being partially positively charged, just as we can think of this carbon as being partially positively charged. Okay, so when the Br minus attacks, it's more likely to happen at the more substituted carbon. Right, so then the product of this or the two possible products of this, are a wedged bromine there and a dashed bromine here, or a dashed bromine here and a wedged bromine here. And that's basically all there is to it. These are the two products. So you had the right idea. You just needed to show the stereochemistry and show that these are anti across the double bond. There you go.